Hello everyone, we are a team from Zhejiang University and I'm Xiao Ziyang. Today I'm excited to introduce our latest work, DoveDB, a declaration and low latency video database. In this work, we have introduced a fancy video database named DoveDB, which served as a database management system designed for videos. DoveDB can not only store videos, but notably it supports a wide range of advanced queries. DoveDB also has a friendly user interface using a SQL-like language, and also the system boasts a remarkable efficiency even when handling complex query. DoveDB can respond within few seconds. Moving forward, let's take a peek at the overall architecture of DoveDB. The system framework, as shown in the diagram on the left, consists of a few key components. The query engine handles users' requests. The storage module takes care of slicing, compressing, and storing videos, and then the real-time ingestion module is responsible for creating indexes for videos, ensuring rapid responses to variable of types of queries. Furthermore, the system employs some model acceleration techniques to speed up the model inference, thus enhancing overall system efficiency. Now let's take a look at the syntax of VMQL, Video Management and Query Language. In DoveDB, users can utilize a very intuitive SQL-like language to create and query videos and manipulate models. For instance, if you want to create a video data source based on a specific video file, you just need to import create video source from a file. This straightforward command will effortlessly create a video object for you. Afterward, you can make use of select statements to query this video. For example, just like the bottom left corner, you can query the number of vehicles. DoveDB's efficiency stems from its utilization of a lightweight video data ingestion scheme. Within the system, we employ a dedicated method to create estimate object positions. This enables us to run algorithms at lower sampling frequencies while achieving outcomes equivalent to those with higher frequencies. In our experiment, our algorithm not only outperformed a classical video process algorithm, OTIV, in terms of speed, but also obtain a higher F1 score. Lastly, let's provide a brief overview of DoveDB's user interface. In this demonstration, we have showcased DoveDB's capability across 120 simulated road cameras. Users have ability to switch between camera views displayed in Zone A and observe the imagery captured. In Zone B, users can across models that have already been trained. Zone C features a simulated road network map for references. To interact with the database and execute a wide range of queries, users can utilize the command line interface found in Zone E. Next up, let's take a look at the demo video of DoveDB in action. Let's start with the center part of the interface, the map. The map is actually a virtual presentation created by color simulation software. On this map, you will notice several camera icons. These icons present the location of the online cameras. Next, the top left corner of the screen. This area is to monitor a total of 120 cameras. By clicking on the drop-down menu here, you can switch between different cameras' views, which allows you to access detailed information for each camera. In the bottom left corner, you will find the models already stored in DoveDB. As you can see, there are currently 4 models available. Now let's look at the scenario 1. In this scenario, we will train a model for detecting red vehicles and deploy it on some online cameras on DoveDB. First, we will use the create statement to define and train our model. We will be using YOLO v5 Nano as the pre-trained model. Furthermore, we will use pre-stored dataset on DoveDB as the training set. This dataset consists of hundreds of images, and the pseudo label are generated by YOLO v5x. After waiting for some time, our model will be trained. You can see a new model is added to model area. This is the one we just trained. Now let's deploy this model on online cameras. To do this, we will use create monitor events statement. The monitor will provide event alerts based on the signals produced by model. As you can see, when a red vehicle is detected by model, a video frame will pop up on the camera's icon. In this way, you can have a global view of what is happening on the map. The deployment of this model is interactive, so you can simply press Ctrl+C to determine the model's running. Next, scenario 2. In this scenario, we are going to do a more challenging task. We will deploy a multi-object tracking model on all 120 online cameras at the same time. To achieve this, we will use a pre-trained MOT model available in DoveDB. Just like before, we will create a monitor event to implement this feature. Once the model is deployed, you can hover your mouse over the camera icon to see the footage captured by a particular camera. This footage will already be processed and annotated by MOT model. Additionally, you can pay attention to the camera section on the left side on the screen. It will give you a clear view of the monitored areas as well as the bounding boxes given by MOT model. In fact, during this process, DoveDB not only performs inference on the video frames but also creates a lot of indexes in the background, which plays a crucial role in improving the efficiency during offline queries. Finally, scenario 3. In this scenario, let's explore the capabilities in offline query of DoveDB. Suppose we want to find out how many vehicles have passed by camera 102 in the last 300 seconds. We will use a select statement, which is similar to those used in traditional relational databases. We use count operator to calculate the total number of vehicles. As you can see, DoveDB returns the result with very low latency. This can be attributed to the indexing built before. Next, let's test a top K query. Suppose we want to find the top 10 frames with highest number of vehicles captured by camera 0 in the last 300 seconds. We will use a select statement again, but this time we will select the frame. After pressing enter, you will notice that the retrieved frames updating in real time on the right side of the screen. Once the retrieval is complete, the command line interface will return the all relative information as well. As we demonstrated, DoveDB offers impressive capabilities in model training, deploying, online query, and offline query, making it a powerful tool for analyzing videos. Thanks for your attention.